Hey everyone, and welcome. Today we are jumping right into Python. But forget the boring, dry textbooks, okay? The absolute best way to learn to code is to actually build stuff, real things that actually work. And that is exactly what we're going to do today.
Think about it for a second. Have you ever been playing some simple little game and a thought pops into your head like, you know what? I bet I could make this. Well, guess what? You're totally right. You can, and it's probably a lot easier than you think. So that's the goal here. We're going to take just a handful of Python commands and turn them into actual fun programs that you can run, you can test, and even show off a little. So if you're ready, let's get into it.
Every massive app you use, every piece of software, it's all built from the same basic building blocks. These fundamental ideas are where it all begins. And today, we're going to master those first essential pieces. Okay, our first project is a total classic. And for a good reason, a simple calculator. Why? Because it's the perfect way to learn the absolute core logic of pretty much any program. You take something from the user, you do something with it, and you give back a result. See, this is how a programmer really thinks. It's not magic. You don't just tell the computer, hey, build a calculator. No, you give it a super clear step-by-step recipe. Get a number, then get the operation, then get the second number. You see that logic? It's just a sequence of really simple commands that, when you put them together, achieve a bigger goal.
All right, and here's our first look at some real code. This int input might look a little weird, but it solves a really important problem. See, when you type the number 5 on your keyboard, the computer sees that as text, kind of like the letter T or Q, and you can't do math with letters. The int part is the hero here. It tells Python, hey, that character 5 you see, I need you to convert that into the actual number 5 so we can add and subtract.
So, the computer has the numbers. How does it know whether to add or subtract? Well, it uses something called conditional logic, which is basically like a fork in the road for your code. The program looks at what the user typed, let's say a plus sign, and it asks a question, is this a plus? If the answer is yes, it runs the addition code. If it's no, it moves on and asks, okay, well, is it a minus? This if, elif, else structure is like the program's brain. It's what allows it to make decisions.
And this is what separates okay code from good code. Thinking ahead. What happens if the user tries to divide a number by 0? Well, math breaks, and your program is going to crash if you're not ready for it. So a good programmer adds a simple check, right? Hey, if the second number is 0, don't even try to divide. Just print an error message. We're planning for these little edge cases to make our program solid. Okay, we've built a tool that takes an input and spits out one output. That's awesome. But now, let's build something a bit more dynamic, something more interactive. Let's build the classic guess the number game.
So here's the setup. It's super simple. The computer's going to pick a secret number, let's say somewhere between 1 and 10, and our job is to write the code that lets a player figure out what that secret number is. To make this game work, we need a brand new, super powerful tool, the loop. A while loop is what makes a game feel alive. It lets us repeat a bunch of actions, like asking for a guess and then giving a clue, over and over again, without us having to write the code 10 different times. It's the engine of our game.
And check this out. This is the line of code that runs the entire game. It's practically plain English. That is not equal to symbol just means is not equal to. So this line is literally saying, as long as the player's guess is not the same as the secret number, keep doing everything inside this loop. The second they get it right, that condition becomes false and poof, the loop stops.
So what's actually happening inside that loop, every single turn? Just 3 simple things. First, the code checks if the guess is higher or lower than the secret number. Second, it prints the right clue to help the player out. And third, it asks for another guess. And that cycle, guess, clue, just keeps on going until they win. That's the core of the game right there.
We have a working game, which is fantastic. But now, let's level it up. We can take this simple script and add a few key features to make it feel like a more polished, more complete experience.
Just look at the difference here. On the left, that's our basic game. It works, sure, but it's a little flimsy.
On the right, though, that's where we're headed. We add a guess limit to create a little tension, we handle bad inputs so the game doesn't crash, and we let the user play again, which just makes it way more fun.
So how do we stop the game from crashing if a user types apple instead of a number 5? We use this beautiful idea called try and accept. You basically wrap the risky code, the part that could fail, inside a try block. If something goes wrong, the program doesn't explode. Nope. Instead, it just jumps down to the accept block where you can print a friendly message like, "Whoops, that's not a number, try again." It's literally a safety net for your code.
And adding that 3 guess limit, it's just a small change to our while loop. We'll create a new variable to keep track of how many guesses they've taken. We started at 0 and add 1 after every try. Then, we just change the loop's condition to say, keep looping as long as the number of guesses taken is less than our max of 3. Easy.
And finally, to make our code really clean and to let people play again easily, we use something called a function. The best way to think of a function is like a neat little box that holds all of our game's logic. We can give that box a name, like play_game. Now, instead of one long, messy script, we have this clean, organized, reusable mini program that we can just call anytime we want the game to start.
So let's just take a step back for a second. In just a few minutes, you haven't just built 2 little projects. You've actually put together an incredibly powerful toolkit of core programming concepts. And you can use this toolkit to build almost anything.
And really, this is it in a nutshell. This is your brand new Coder Toolkit. You've got variables to store information, like the secret number. You've got conditionals, so your code can make decisions, like checking if a guess is too high. You've got loops to repeat actions, like asking for a new guess over and over. And you've got functions to organize all your code into neat, reusable boxes. With just these 4 tools, the possibilities are just huge.
So you've seen how just a few lines of code can become a useful tool or a fun game. You now have the fundamental building blocks in your hands. So the only real question left is, what idea are you going to bring to life? What are you going to build next?